Right. Hey, Hannah, um, and Morgan. I'm seeing everybody. Uh, I hope I'm saying this right. Punam and Frederick. We know Frederick. Hey, Frederick. I think we might have a meeting with you soon, actually. All right. So, folks, welcome. It's great to see people from all over the world. And today, this is kind of a pretty controversial maybe take that we're taking in this talk, but this is really something that I believe. And I this is just one man's opinion, right? Based on our experience and what we've been able to do, and kind of we'll furnish that with some proof because other people think the same, other people who maybe have more authority. But most importantly, I think we're going to talk about a few things, a few basic things that people need to know to get started with coding and get started with kind of this journey. And yeah, so let me just start by saying, by giving you kind of a little bit of an intro to Crowdcast, which is this environment we're in. So we're all, in kind of the middle. You see my deck and myself. That's our stage. So you're not on it. So don't worry if you have to yell at your kids or do dishes or anything like that. We can't see you. Your main mode of interaction is going to be here on the side on the chat, as some of you have already noticed. We also have an ask a question, a Q&A button where I encourage you to ask your questions if you want us to kind of, in an orderly way, go through them and give answers. There's also the ability to sort of vote on other people's questions so that we're going to pick the ones at the top and definitely get to those. And we have a poll in the field just so it can kind of start seeing how, what people levels at, and, what's level is, people's experiences. And I'm very excited to kind of see that as it tracks. For some of you, this might be a little basic. For some of you, this will be exactly what you need to unlock the ability to start participating and contributing in code. The webinar is recorded. This was asked before, but anybody who has this link that brought you here, this current link, this is where the recording is going to be saved. So just get back here, 5 minutes after the talk, and you'll have the recording right there. So a couple of points to say for introduction. So my name is Eran Dror. I'm the co-founder and CEO of Evermuse. And Evermuse is kind of a co-pilot, kind of like a Cursor or a Claude Code specifically for product work, specifically for kind of shaping features, figuring things out based on 100% of your customer feedback. So we're not going to push it much today, but just to kind of give you some background. Back in 2019, I actually wrote my thesis on AI safety. And I wrote it from a Buddhist perspective because that's what I was studying at the time. And that got me really thinking about this problem of misalignment and how technology is moving so fast, and AI is going to get more and more powerful. And we humans are at risk of being left behind. And I think, just the recent piece of news that I read is the Claude's latest model, Claude Mythos, is not going to be released to the public. Because it is so good at hacking. It found thousands of flaws in every open source system, every basic system of the internet. It's so good at it that if they release it to the public, there'll be mayhem. The foundations of society will crumble. So that's a real thing, right? And so the question that kind of was driving me is how to keep AI connected to what we need as humans, right? And that's sort of the idea of Evermuse. Today we have 1 hour. I may stay longer if we need to, but we also have a meeting, so I'll try to keep it within 1 hour. And we're going to cover three things. One is kind of how is AI changing product roles from what we're seeing, and I'd love to hear your take because this is, your opinion is as good as mine. Two is, how can product folks use AI? And I'm a big advocate for AI coding and kind of will focus mostly on that. And then 3, how should teams work together across functions? How do you work with dev in this new reality? How do you work with other parts of the business? So let's just dive right in. And let me remind you, if you have something to say it in the chat. If you have a question you want us to answer, ask using the question tool. Product is changing. So coding is now about 10x faster and about 100 times cheaper to produce code. Engineers using AI and also product people using AI routinely create hundreds of thousands of lines of code, building new features, in 20 minutes. And so that changes a lot of the basic assumptions of what it is to do product work and how product work works and how much time you have to do product work, right? And product clarity is now becoming the bottleneck. So here's a quote from Andrew Ng, who's one of the big names and founding fathers of machine learning and AI. He says the bottleneck is deciding what to do. What do we actually want to build? And here's a bunch of other quotes for other people kind of saying the same thing. Product management, product clarity, product decisions are becoming the bottleneck. So this is from Vercel and Linear, the CEOs. This is from VCs. This is from product people, Mike Krieger at Anthropic, and more and more and more. And so, what does it mean to become the bottleneck? So I think this is both good and bad. So on the good side, it looks like the trend is we're actually starting to move towards a 1-to-1 product and dev ratio again. So it's been a long time since that was the case, and today it looks like pairs of product plus coder together can really build a phenomenal amount of great features. And so what we're seeing is actually product roles and product is hiring faster than dev, which is pretty incredible for the first time. But the bad side of this is that slow to adapt product folks could be replaced or sidelined. And so I think it's time to get back to the basics. So what is product work anyway? To kind of remind ourselves, how did it start? Why are we doing this? And I have a theory, or I have a name for it. My claim is product work is essentially shaping the features so that they're ready to code, right? In the beginning, we might have some sort of idea of what we need to build, but it's very vague. We need to do the research. We need to understand what people actually want. We need to make key decisions about how this thing should work, from experience-wise, design-wise. There's a bunch of decisions to be made so that we have a shaped feature. And then we need to get it ready for development. So, traditionally there were programmers, there were engineers, and they didn't really want to do a lot of meetings and meet with customers and understand what their requirements are, and think about things like user experience. So this role was created for that, right? And now we're in an age where coding is different, but shaping is still important. But what we noticed, or beginning to notice, is the AI creation flow is different than the traditional flow. So in the old way, as a product person, you would maybe scour different customer channels. You talk to people, you talk to management to understand what to build. You try to analyze all of that stuff. You put it on some sort of prioritized roadmap, right? Like you say, okay, this is more important than this, and this will bring in more revenue than this. Then you choose the top features from that roadmap, maybe a couple, and start shaping them. And you had plenty of time to shape them because the team was still working on last month's features. And you created PRDs, which are very detailed, and wrote dev tasks. And then that went to kind of a human coder. And what we're seeing emerge is something quite different. You can connect all of these customer channels and sources to an AI that can learn and highlight and find opportunities. That AI can work with your team to shape the spec. And because AI is operated by language, these are large language models, that's how they started. the language of the spec really, really matters. And we'll get into it in a bit, right? But the AI can help you by saying, hey, here's what's important to customers. And then the product person can bring in their tastes and their opinions and, their aspirations. And the engineer can come in and say, hey, it's important to include these couple of notes on how to do it on the technology side. And then once you have that spec, you can submit that to AI coding tools, and you have a build. You have a build sometimes 20 minutes later. And so, then comes the part of kind of reviewing what was built, testing it, and managing the revision process, right? So this is the new way that's emerging to do product. And by the way, that's exactly what Evermuse does. So this is sort of, we built this AI agent to help you throughout all of this process. And so, there's a question of how product folks should use AI moving forward. And I think it's at every step, right? We use it in research. We already use it to analyze calls. We already use it to write PRDs. But I think we should also ship our own code, because there's something weird about product designers and product managers. There's always been this kind of weird disconnect. And the way that I kind of think about it is like, if you're a designer of furniture and you don't know about wood or about joinery or about, basic carpentry, right? You don't care about how things are put together, right? That's a little bit of a weird thing. And I think we kind of got away with it because it was, because technology is so complex and it was understood it would take a really long time to teach you how to code, right? But I actually think this is correcting that AI is correcting that and bringing us closer to understanding what we're actually building, understanding the design, not only at the surface level, but all the way into it, like all the decisions made in how the data flows and how processes are constructed, the logic, the business logic inside of it, fully, deeply, right? And really, AI can allow you to do that now with your app. If you kind of point it at your GitHub repository, you can start understanding things at a much higher level than you could before. So I think that's pretty exciting, actually. And let me pull up the next one. Okay. So this is just not just me saying this, right? So there's a few influential people here saying, really, we think coding and creating code and vibe coding is a really important part of the PM role moving forward. And we have the VP of product at Shopify kind of describing that. We have Google AI PM talks about how important GitHub is. We'll get to that. And I think people who refuse to look into code and to generate code and to use AI to understand code better are going to be looked at kind of like that designer who refuses to understand wood and like joinery and like the basic stuff, glue, right? The basic stuff that puts together chairs. And they're going to be looked at with suspicion because it's now so easy. There's really not an excuse anymore. And so I want to talk about skills. So let's start with some practical skills and mental models for how to use the AI. And this is all coming from my experience. We've done a lot of research about kind of what other people are saying. But most of this is coming from my experience. And, the first thing is to kind of remember here is AI is language-based, right? If the traditional product work might have been, hey, here's a design prototype. Here's user journey annotated with like arrows and stuff. With AIs, you really have to bring it down to language. Here's the feature. Here's what it should do. Here's, what happens when you click this. And actually, the more you trust the AI in the details of implementation, the models today are very, very smart. They'll probably surprise you. Sometimes it's better to offer a short prompt and see what comes back, rather than a very, very detailed prompt where like, and there's the button here, and this is what it says, and then there's a line. Like, why not let it build it first and then decide what the button says, right? and you can sort of get new ideas, and often they'd be better. So kind of getting really good at language and the importance of that spec is really meaningful. Second thing is we're seeing kind of a move from wireframes to what I call interaction experiments. These are pre-prototypes, I would say. This is something that you can put together in 5 minutes on Lovable just to kind of see how it feels to click around a certain idea that you have. This could be like an equally quick thing with Miro. Now has these Miro prototypes that are not really meant to be pixel perfect or necessarily very pretty, but they're very, very fast and you can sort of explore ideas. There's UX Pilot that does similar things. So it's much more about, hey, I have this idea, let's throw it out there. Let me see how it works. Let me kind of try to interact with it. Then we have kind of the Figma prototype, the more fleshed out, super design prototype that we put a lot of work and management into. And I think that's gradually being replaced with a real code prototype. And a real code prototype is actually very easy to do, and it's pretty easy to get it to look right. So if you start with something that looks generic, but you have good taste and you give it a lot of feedback, and if you have the designer eye, very, very rapidly you can get it to look amazing. It probably look better and more real than any prototype you've ever had. And so we see people kind of skip that Figma prototype and go straight into code prototype. And that's definitely what we're doing. And I haven't used Figma to design a screen in probably a year. So it's actually right about a year. When we're building a prototype, I think, it's important to remember, like right now, Opus 4.6 and Codex 5.4 and these kind of latest models are smarter than most software engineers. I mean, they're better engineers than most software engineers. They can write better quality code. They find issues faster. They review their own code faster. They have many limitations, and sometimes they do crazy, unexpected things. And they definitely don't have the full context that a human has. But technically, it's possible for you, without understanding code at all, to build something fully real. So I wanted to pause here and kind of say, well, what's really the difference between a prototype and just building it real? And to me, it's the speed of iteration on just the experience and the front end without worrying too much about back end and logic, right? And so when I build a prototype, I literally type this. I say, I'm building this feature as a prototype first. So I'm still using our real code base, obviously locally in a separate branch, but I'm still using our real code base, but I'm saying, hey, I'm building this feature as a prototype first. So please don't make any backend changes and use only mock data, but make it realistic, right? And just by saying this, and sometimes I have to remind it, if I start a new thread, I have to remind it, then it's a prototype. And I can iterate very quickly on the front end until the experience feels right. And then either I want to make it real myself, or maybe I hand it off to an engineer to if the backend is going to be complex. There are 3 principles that I use when I want to build something real. And these are 3 things that I do. And again, I don't read code. I haven't programmed since high school. The last programming language I learned was C++. So it's not helping me. It's not helping me here. And I don't remember much of it. But here are 3 things that really work for me when I build production features that actually end up getting merged as is, or very close to as is. I start by researching the technical aspects. So if there's something that seems challenging or new in the feature, I might have a conversation with Claude Code before it and say, hey, what are the solutions out there? What libraries are available here? Is anybody else doing it? What are the best practices on something like this, right? And just kind of as a layman to start understanding, okay, there's what seems to be the right technical approach. Are we converging towards something? And if we do, all I have to do is include that in my prompt. Then we spend, I really spend maybe 5-10 minutes thinking about the logical dependencies of what I'm building. So that's a step that designers and product people sometimes don't have to think about. And traditionally, it's more an engineering thing. But if you're going to build it real, you have to do it. And so, for instance, if I have I have a feature. This is a real story. We're working on a feature where real customer requests are linked to the customer profile that you're talking to, so you can kind of filter it by the customer, understand what's important to what customers, connected to revenue, stuff like that. But we haven't built the customer request feature yet. So what we're collecting now is we're collecting a lot of signals like needs and pain points and a lot of stuff. But actually, explicit requests we weren't collecting, right? So when I was coming to build this customer linking feature, I was like, wait, logically, that depends on requests already being in the database. So why don't we start with the request, right? Let's get that done right. Oh, and by the way, for us requests, I wanted to implement that as a custom signal, because we're building the ability to customize exactly what you're collecting. And so I was like, actually, before that, let's build custom signals. So I wanted to do this feature that's a big payoff, right? Like connecting everything to customers. But I'm starting with the ability to set up customer signals because logically it depends. These things depend on each other, right? So you have to think about that. And then building it in the right order. That's mainly the difference between being kind of a designer, product person, visionary, and being someone who actually builds, is knowing what the right order to build things. And so that's I think really important. Now, another thing we discovered is that planning really doesn't scale. So if let's say you have this vast vision, which a lot of product people do, and I certainly do, and you just start coding all of it at the same time, right? And you're so excited about it that you don't stop and test at every point that what you build actually works. Then, you can spend a couple of very pleasant days doing this, but you're going to have to throw away the whole thing because a bunch of little errors and wrong assumptions and kind of bad design accumulated, and not only will nothing work, it will take you way more time to untangle why nothing works than building the whole thing from scratch. So you're going to throw out the whole thing. Whereas if you kind of thought about the step by step and you built one step, tested it, verified that it worked, committed it, we'll talk about that in a second, and then built the next thing on top of it. Verification scales, testing scales. You can build it as complex as you want if you just verify that every step actually works. And so this is a little cautionary tale. I've lost definitely days building amazing things that never actually worked at the end. Okay, so I've skill number 2 is what I call understanding AI agents, right? And so let's talk about that for a bit. So what is an agent? And really the first agent, some of you have played with Cowork, right? And so you're starting to understand what it means. But really, coding agents were the first on the market, the first ones to kind of give us a sense of an agent that can do stuff, not just chat with us, but do stuff. And so here's a definition, an old definition from Anthropic. An agent is an LLM running in a loop with tool use. What does that mean? That means that the chat doesn't end until it's accomplished a certain goal. So it's like back and forth. Okay, I'm not done yet. Let me continue. I'm not done yet. Let me continue. And in addition to that, what the agent can say is it can tell the system, I want to use this tool. Please use this tool in this way. And then get results and then proceed from there, right? So it's really built on the same foundations of an LLM, but it can do stuff for you. And anybody who's used Claude Code, obviously gets that. So that's number 1. So I think kind of understanding these are agents. They have tools. They have access to various tools. They can edit files. They can look at files. They can do searches. They can search the web to find documentation. They can, if you paste a link to a piece of documentation, they can look at it. If you found an open source project that does something similar, you could just send them the GitHub link and say, take a look at how they do it, right? And so it can use tools and kind of work with you, which is amazing. So that's number one. Important lesson here of working with agents is remembering their context window limitations, right? So even if you're looking at the kind of cutting edge models of Opus 4.6 and Codex 5.4, they have about 1 million tokens. And a token is about roughly a word. It's about, it's about 75% of a word. So about 1 million that they can fit in. However, they're not equally proficient across a large context window. So as you start working with them for longer, or giving them more complex tasks, reading multiple files, doing research, understanding what even needs to be done, they get into what some people call the dumb zone. So essentially, what you want to do is compact your prompts, the context, the work as much as possible so that the hard thinking happens still within that 40% of context window. Now, it's kind of hard to do because in Claude Code, for instance, they don't actually reflect back to you where you are. Cursor does, Cursor and some other tools do show you where you are. They show you the percentage of how much you've utilized for each model. And that's very, very helpful because the best work happens in the first 40%. In fact, once you've gotten to 40, 50%, unless it's a very easy task, I wouldn't let it finish. I go into a new thread and I continue from there. But that's a really important thing to remember. No, these models, these tools are including all sorts of things to ameliorate that. And Claude Code is, they have compaction and they have all sorts of tools, sub-agents to make better use of the context window. But fundamentally, if you want to guarantee really high quality work, just don't work too long in a single thread. That's just kind of a truism. Another thing to kind of understand with agentic, and this another pattern that's emerging here, is human needs to be on the loop and not in the loop, right? The loop is the AI running, using tools, figuring out how close it is to achieving your goal. The human is not part of that loop. The human gives permissions to the agent, to the permissions the agent needs, and then the human is observing and maybe reviewing at key points. And maybe there's some key points where the agent has to stop for a review. So for instance, the agent wrote a development plan. Now the human can read it and approve it. So this is on the loop rather than in the loop. And that's a model that's kind of takes getting used to. Okay. So now let's get to the super practical things. And by the way, if you have any questions, keep asking in the questions. I'll stop towards the end and kind of try to answer as many as I can. But choosing the right tools. Okay, so this is my understanding, having used all of these tools, but there's a lot more tools that I haven't used, especially a lot of cheap open source tools that I haven't used. But essentially what I see here is kind of a junior coder versus a senior architect. Like, what's the level of technical ability that they have? And the top models, Claude 4.6 and Codex 5.4, are about equal, and they're very much at the senior architect level. But then there's also another axis that you need to take into account, which is more collaborative versus more independent. And this goes down to the training and the tools that are built around these models. But codecs tend to want to get your instructions and then go build for a really long time on its own, not talk back to you. Doesn't like working, and it doesn't feel as friendly as Claude, and it doesn't feel like a collaboration. It feels like that maybe weird engineer that you had that's like really good at infrastructure and really good at high level engineering, but doesn't really like to talk. So he's asking you to submit specs in writing, and you'll see him at the end of the week, but he would have built something incredible, right? So that's Codex for you. And in Claude, I would say, is at the same technical level, but he's more big. He's more big picture, and he's much more gregarious and collaborative, right? So when I work on something that's very front end heavy, when I work on something where there's going to be back and forth, um, Claude is the tool, is the model that I choose. And the importance of the model is, um, we like to say the model is the engine, and the tool is the rest of the car. And so we'll move next now to the tools, okay? And some of you have already started messing with these tools. And I think, I put them on an axis from like closer to design versus closer to code. And my encouragement to everyone here is to move closer to code, closer and closer to code as you can, right? So if you look at Figma Make, yes, it can write code, but it lives in Figma, and it's very much about creating things that are kind of Figma adjacent. Google Stitch is similar. UX Pilot is similar. There's other tools like that. Then there's kind of this middle tier, Lovable, Replit, V0. There's a couple of others that are very intentionally easy to use. They have chat with not too many options. They even kind of hide the code that you're writing. You can find it, but they're not really front and center. Typically what it has is chat and the app that you're building side by side. So you chat and the app gets built. I think that's a lovely way to start. That's how I started. I started with Lovable. I migrated to Replit. Then I migrated to Cursor. And now I'm using Cursor, Claude Code, and Codex all at the same time. And I think the more you move to the code element, and it's not that hard because you don't actually have to read or understand code, but those tools are way more powerful. They give you more options, and they also they themselves have more power within your repository, right? They can do anything. They can so you can really plug in any repository, any product, any language, and they can handle it, right? Whereas Lovable and Replit, in order to make it easy, both of them, for instance, have made choices on what database to use, right? So Replit has its own database. Lovable works with Supabase and Always, right? So you actually have to put in a lot of effort if you want to get them to use something else, and they'll keep getting back to using it. Whereas Cursor, Claude Code, Codex, they'll figure out whatever you're using, and they'll just use that, and they'll use the existing methods that you've already built, and that's really what you need to build production code. And so I would strongly recommend to kind of embark on this journey with Cursor, Claude Code, and Codex. Rusina, do a demo. I think we have limited time, so I'm going to show you a little bit of how I use it, but I think it's more important to kind of to give you the tools to get started. And so we'll try to, there's definitely one prompt that I'm showing. So it's important to understand that a tool matters more than the model. So the model is the reasoning engine. It kind of decides how smart the tool is going to be, but the tool is really everything else. It's the entire rest of the body, right? So the tool decides what the agent knows about your project, what tools it can use, what permissions it needs, what rules it follows, what modes it has. So Cursor has this amazing plan mode and this amazing debug mode that other tools don't. And what skills it has access to and can learn, right? So picking the right tool, and I encourage you to do like use real kind of production tools, is going to make a big difference. So let me show you like what it looks like, right? So we have Claude Code, where on the side, you see all of your conversations, and you have a prompt here, and you can choose what branch you want to work on and whether you want to work in the cloud or locally. You have Codex, which is exactly the same thing, slight modifications, but you have multiple projects here, but you have threads in each one, and you have chat. And you can choose what branch to work on and whether to work locally or in the cloud. And then we have Cursor, which is, surprise, surprise, a chat with conversations on the side, multiple projects, and you choose which branch you want to work on and whether to work locally or in the cloud. And there's more options for each one, but this is really the essence of all, right? So now we're going to get into kind of the talking to AI effectively. So, I'm going to give you a few pointers and an example of how we do it. But overall, like when I want to start building something, I think of the agent like it's an expert coworker, like a really experienced engineer, but they're new to my company and the project, right? So, kind of normally, I'm going to give them the context they need. I'm going to explain my situation. I'm going to explain what I'm trying to do. I'm going to give them all the needed context. I'm going to ask them for advice because I respect their expertise. They know things that I don't. I collaborate with them respectfully. I don't shout orders at them. I listen to what they have to say. And very importantly, and this is actually proven with LLMs, leaving room for pushback. If you don't allow room for pushback, if you're like a dictator, then the LLM was going to try to oblige, even though what you're asking for is A, maybe wrong, B, there might be important questions that need to be decided, and C, it might actually be impossible, right? And so it will try to do it, and it will cause a lot of damage, and it will be disaster, and you won't understand why. But it's because you were not being nice to the agent, and it's kind of funny that we have to be nice to algorithms, but we do in this case. And the quality of your prompt really changes everything. So when the task is easy, it could make a 16% difference. This is based on research. When it's medium complexity, that's already more. And when you're working on a really hard task, the quality of your prompt, the thinking, the decision, the choices, the context makes a huge difference, right? The harder it is what you're trying to build, the more important the quality of the prompt is. And there's this 5 W's framework. Actually, most people do 4. I do 5. But starting with why, which is, think about it, this is how you would talk to a person. You would say, hey, I'm trying to do this and this because our customers are having this and this problem, right? That's really important for the agent's decision making as it's working on the problem. So always start with why. What's the problem? Why are you doing this? Then I immediately say where. Like this part of the software, this is what I'm trying to do. I'm trying to change this part of the software that immediately gives them context that they can go and look at files, the agent can, and understand what's there now. Then you have to describe what, or what am I trying to do? And then how is like all of the important requirements for how this should work, what patterns to follow. If it needs to be similar to something else that's already done, like, hey, use the same box card style that we're using in this other feature. Then say that. Like, but if this is also a good place for technical notes. Hey, use this library. And then when is like, hey, it should do this under these conditions, but maybe not do this under these other conditions, right? So just by following this, you can come up with a great prompt. Now, I want to give you a recent prompt that I would give a B minus 2, but it's important to understand it still worked. So agents are getting smarter and smarter. They'll figure it out, and they'll ask more questions. If you give them a prompt that's lacking, they'll ask you questions before they start. But also, maybe they build it a little bit wrong, and then you can tell them to fix it. So it's not the end of the world. It's really, the important thing is to just get started. But here's the feature. I was building the other day an add to chat sidebar. Well, so we have a chat in the system, and we have add to chat about on a bunch of things like meetings and shaping notes and opportunities. And we have that add to chat button, but it would take you to the main chat. So you'd lose your context and you go to the main chat window. So what I wanted to do is add this chat sidebar. So if you hit add to chat, it would open in the chat on the sidebar. So I describe it here. I say when you select add to chat from these places, instead of going to the primary chat, it should open a new chat sidebar right where you are with the added context. So this is the what. And then the rest of it is kind of how. The chat sidebar is a side panel that pushes the rest of the content to the side. It doesn't cover it. And has the full functionality of a single chat thread, but without the threads picker sidebar, which we have on the main chat. we should have an icon for changing threads and for composing a new thread. The chat sidebar should be 400 pixels width by default, but resizable. Okay. So this, I mean, just compare that to like a huge PRD that we used to write before. This would sort of work. I would recommend fleshing it out more. But if you're lazy or you just want to get started, it's not going to be the end of the world. Now, it also partly it works because we already have the main chat working. We have the methods. I don't need to explain too much what chat is because it already exists, right? So that's an important distinction here. So B minus, but this totally works. Okay, so let's talk about teamwork across functions, and we'll get to some of the skills that are blocking that. So McKinsey found that Cursor ships twice as fast when they have a PM and dev pairing. So PM works with a dev. And that PMs that prototype first have way better specs, way better understanding of what needs to be built. And it also makes the engineers' role a little bit different. They review, they harden, they don't have to translate from language into writing brand new code. They have code and they can kind of look at it and evaluate it. And here's a plan that I would give a PM that is kind of starting to code for the first time. This is what I would hope we can, you can start doing, and then some of these are maybe exaggerated safety checks that you can start taking off. But here's a good place to start. Start by writing a really clear spec for AI for a feature you're working on. Use the 5 Ws. Show it to an engineer. Have a 5-minute conversation with them. Say, hey, I'm working on this feature. I think I'm gonna try to let Claude build it, or whatever you're using. What's important? Is there anything that's important to add here? And the engineer might say, oh yeah, you should use this library, or actually make sure that it reuses this function and doesn't write a new one from scratch, or make sure that all of these activities happen only in the backend. Right? So it might have a couple of notes for you that you can just add. It's literally a couple of lines of text that you can add to your spec. And so after this consultation, you have a spec that's ready to submit. Go into Claude Code or Cursor or whichever one you use, and submit it in plan mode. When you submit it in plan mode, the agent is not going to write any code yet. It's going to do a lot of research. It's going to write a development plan that's very, very detailed and give it to you. And so I think that's a great place for, as you're building your confidence, to show that plan to an engineer and give them, it's usually a markdown file you can copy. By the way, we have a place where you can manage these plans inside of Evermuse, but it's a markdown file. Send it as an attachment, call them to look at your computer, ask them to spend 5-10 minutes reviewing it and letting you know if they have any comments. Let them change it if they want. Once it's ready, don't ask them to build it. You build it. Take the approved plan, submit it yourself to a coding agent. Learn how to build it locally on your machine. Once it's done, run it locally. Test it. See whether you got what you expected. You're probably going to have some notes. Give the agent your notes to improve it. When you feel like, oh, this is good enough, I actually want to save this, commit it to a new branch on GitHub. So that it doesn't, you're not at risk at kind of committing it to even your development environment where it would bother your engineers. Commit it to a new branch. And when you feel like, okay, this is ready for review, I want the rest of the team to do it, create a PR. And some of you might know what a PR is. I'll explain a little bit more. And then the engineer gets a finished piece of work. We can talk about testing, and there's a lot of automated testing that needs to happen on these PRs, but that's the engineer's responsibility. Then the engineer can review it if there needs to be changes or the feature needs to be completed because maybe it's just a prototype at first. They'll do it, and then when they feel it's ready, they'll merge it. Right. So this is a starting plan that is completely practical, doesn't risk anything. And you can enact today, and you can start working in your real code base building a new feature like that. And I strongly encourage you to actually try that. You're going to have to learn GitHub. So I actually didn't, I understood the concept of Git and GitHub, but I never had to use it myself. Luckily, agents can really help with that. So you just tell it what you want, but you still need to understand how GitHub works for this to happen. And this is a quote from a senior AI PM at Google who was hired based on his GitHub contribution. And again, not an engineer, doesn't read code, but was working with AI so much that he actually had a whole GitHub portfolio that was very impressive and got Google to hire him. So your title matters less, your GitHub matters more, right? So here's how you start learning how to use GitHub. First, go to your GitHub, hit that green button that says code, and clone that repository to your machine. So all you have to do is copy that link for the repo, paste it into Claude Code, and say, hey, can you clone this for me locally somewhere? That's all you need to say. It will do it. Now the app sits on your machine, the code, and you can start editing it locally without hurting or messing anything up. So there are really 4 concepts you need to understand about GitHub that would really unlock you. You need to understand what a repository is. You need to understand what a commit is, what a branch is, and what a pull request is. Once you understand these 4, and I'll explain them all right now, then you're good to go. So a repository is where all of your code is saved. Typically, a repository is the same as an app. So if you're typically, if your project has an iOS app and a web app, each of those will be a separate repository. Though we are seeing a trend towards single mono repositories. But typically, a repository is an app. It's all the code belonging to that app. Okay, so that's all you need to know about repositories. So this is kind of a way to think about it, is there's all the code and it's versioned, right? So you have all the code, but it's kind of like a superpowered Google Doc. You have all the history of whatever has happened to the code from the start. And then we have commits. Commits is a single milestone in the code. It's a set of changes that you made to a set of files, usually as part of creating a specific feature. It has an intention, right? You don't just commit some random stuff. But you could also commit fixing a typo. If you fix a single typo, you can commit that and say, fix the typo, and that's a commit. But typically a commit is a few files that change, and it kind of creates a new version of the code. And it's a moment of commitment, right? So the commits are on this timeline. What you see here at the green dots, those are commits. The next step to understand is the branch, right? And so code is really complex, right? So sometimes you start to work on something and it ends up being a quick fix. So you work on it for an hour, you create a separate branch because you don't know how much will change while you're working on it. But after an hour, you're like, actually, this is done. So let me merge that quick fix. This branch, I'm going to merge back to the main branch, right? So this is kind of the main branch, and now it becomes part of the code for everybody. But you might also be working on a feature. A feature typically is multiple commits. Every time something works, a little part of the feature works, you commit that. And then you're like, okay, the front end now works. Now let's make it actually connected to the database. Okay, now it's really connected to the database and saves. So I'm committing that. But now I want to polish it, so I'm committing that. And then at some point, you're saying, okay, this is ready, and I'm going to merge it back to the main branch, right? But sometimes, like what I described, I was working on a feature, which is custom signals, and then I say, actually, requests should be a custom signal. So I'm going to branch off of the custom signals branch and start working on this request branch. And, once this is ready, this will get merged, and then this could just also merge back to it because everything that it depends on is already committed, right? This is the concept of branching. This is how we work in code. This is how we build things and keep things stable for other folks, right? And so essentially, this is the main thing you need to understand. A pull request is just a branch. It's a branch that says, pull me. I want you to review me. I want you to try me and tell me if I'm ready to be merged. That's essentially it. It's a branch that you put a description on, and you are asking your fellow teammates to review and decide if it's ready to merge. Okay, now you know everything you need to know about GitHub, because you don't actually have to learn the commands. You can ask your agent to do it. You'd be like, okay, can you put this on a new branch, because I don't want to mess things up, and it will do it. You can say, hey, I want to merge this back to our development branch, but I don't want to erase anything. Could you do it safely, right? So you could essentially talk to the agent, give them guidance, but you need to understand what Git is to be able to give that guidance. The next thing you're definitely going to need to know is how to build your app locally. And, for those of us who use DOS, we know DOS, DOS was kind of a black, white text on black screen. We know that it's not that scary, the ones of us who are old enough to remember. But for a lot of people, that's a scary thing. But really, let me calm you down. Like, as soon as your engineers give you this, what we have is I copy and paste 3 commands that I need to remember. How to build the front end server, how to build the backend server, and how to install new dependencies. If a new dependency, a new library was added, I need to install. So copy paste 3 commands. They're sitting in my Notes app. I just know how to use them, when to use them in terminal. And now I can have my own version that I'm working on my machine, running and trying it, and trying it and using it on my machine. And Nelson, I'm a little bit exaggerating. I have learned a few Git commands. I can read also the commands that the agent is typing, so I'm learning from that. But I don't want to type Git commands. I could just say, hey, create a new branch, and it does it, right? So my favorite new command, by the way, is please commit and push this to a new branch, create a PR, and drive all GitHub checks to green. So this is like a 1 sentence. What it does is it creates a new branch, it commits and pushes the code, it then creates a PR, writes a description, then it waits for the test to finish. On GitHub, we have automated tests, and if anything fails, it goes and fixes it, pushes again, and it keeps doing that in a loop until the PR passes all the tests, right? 1 sentence, and it does all of that, right? So why would I learn GitHub commands? So this is the time for Q&A. So I'm going to look at it. If you have any questions, please do ask them. I see only 2 here, so I'm going to pick them up from here. So Poonam, I hope I say your name correctly. What has replaced your usage of Figma to create mockups and iterate on design? So I just use code. That's the truth. And I think I actually end up with better designs for it. I build a rough version very quickly. That's kind of mostly almost like a UX or wireframe. It's just like the right data and the right elements, but they still look terrible. By the way, the agent has learned our style, so it looks like the rest of our app, but maybe not very polished. And then I can come in and I say, I don't really like this. Change this to this color, change this, and I want a new style here. Actually, for here, we should use a different component. But all of that stuff within a couple of prompts, a few minutes, and it starts to look really good. And in some cases, I say, okay, this looks basically good, but I'm looking for a nice effect to kind of give this some life, some zhuzh. And I've done this a couple of times. And I actually asked the agent what it suggested. I say, hey, can you suggest some, 10 different effects that could really bring this up to life? What do you think? And it would actually it would give me several effects, several cool things it could do to make it even more special. And then I would try them. I would be like, okay, let's try the first one and give it some feedback, and then decide, okay, is that a good fit? So by keeping it conversational, you can actually do more. And, we've done fancy animations and transitions and cool stuff that I probably wouldn't have done if I was working in Figma. So I think as long as you can make the transition to language, there's no reason why design should be deprecate it. Just use language to say what you need. Okay, so hopefully that's clear. Okay, how do you manage the design system integration? So, Sylvia, like a lot. This is a good question, and there's no perfect answer for that. Um, Cursor now is starting to have some design system related features. Replit has them. Lovable, I think, has a few. Um, a lot of people who build with AI use something called ShadCN. I'm not even sure I'm saying this correctly, but I'll type it for you. I just typed it into questions because that's what I have open. But ShadCN is a library of components that are completely open source and can be styled and designed precisely to your liking. So it's a kind of like a library, like Bootstrap or one of these other libraries, but it's hosted on it's you have the code, so you can design it however you want. So part of the benefits of that is all I have to say is use this ShadCN component, and if we've already used that, then it would already have been styled. And if we haven't used that, I can say use the same styling as our other ShadCN components, right? And so there's some consistency there, but it's really the human eye also that's something that is going to happen. Is a person has to look at it and say, this is not quite right. I think as the team grows and as we kind of think about these issues, there's probably going to be like a design system person who's going to review everything. It will be part of our QA rather than part of the kind of restrictions up front. So we'll create a lot of great components. We can use them, but then someone will look at it, and if there's something new that's not styled right, all they have to do is write a couple of prompts and get it in line. So, okay, hopefully that's helpful to you, Sylvia. Please feel free to ask a follow-up. Okay. Thank you for the overview. I understand the process. Can you clarify how to explicitly or tangibly get started in Claude Code with prototyping and building? Can you share a quick live example? I think you'll find a lot of those online on YouTube, but if you have an existing project, I think I would recommend talking to an engineer and asking them to give you access to the GitHub so you can clone it and you can work on it, because that's the realest thing you can do. And then really all you have to do is open Claude Code, tell it to clone it, and start working on it, building something cool. If you are working on something new, that's even easier. You open Claude Code and you say, hey, I'm trying to work on a new to-do list app, which is everybody's favorite, or I'm trying to work on something. I don't really know what language I want to use, but I want to use it in my browser, so maybe you can help me figure that out. And just tell it what's important to you. Tell the agent what's important to you, and ask it to create a plan. Use the plan mode, and it will create a plan to install, build, and set up this new app. And then it will tell you how to build it and run it so you can see it. So really use that agent like a coworker. Don't think about it as a tool that you have to learn. Think about it like a coworker that can teach you. And talk to it like a person. Like, I know it sounds crazy, but talk to it like a person. Ask it questions like a person. Tell it what you're trying to do, and it will just get it done for you. That would be my recommendation. There's no magic I can show you. It's just me typing, hey, I'm trying to do this. Can you help me? And things happen. Okay. Okay. Hannah writes, thanks for the presentation. If you want to do a prototype or idea for a solution, not yet have a code base, what would you recommend? So if you're early and you don't intend to build something real, Lovable is probably the easiest for a web-based prototype. So just open Lovable, create a new project, give it a prompt, and very quickly, like within minutes, it will build what you asked, and you'll be able to play with it right there, right? And start giving feedback. However, if you're intending to build something that eventually is going to be part of your code base, an existing product, I actually wouldn't start that. I would start with Cursor, Claude Code, or one of the big ones, one of the production ones, because Otherwise, you're creating a ton of work for your engineers and kind of trying to integrate what you've built in Lovable into the existing code base. Okay, so hopefully that's helpful. But Lovable, that's how I started. Amazing for prototyping. Okay, Shadzi, that's me saying, and okay, I think that's really it. Our goal was to get you to go build something, to reduce the level of concern and anxiety around starting to build something. And we're really, really hoping that we did that. We're going to have more trainings, more in-depth training. We also do like workshops that are a full day workshop, 2-day workshops for teams that really want to upskill around this. And there we really do go into like, let's build together, and everybody's going to build something. But in an hour, I just wanted to give you a taste and some basic skills, and hopefully we accomplish that. So thank you very much. And now go build something.